Thank you very much for giving me the opportunity to be here with you and sharing some new insights in primary immune deficiency screening. My talk is going to be purely scientific. It's not commercial. It's not about a product as such. It's about new developments in flow cytometry that help us better diagnose and manage our patients. So the talk will focus on primary immune deficiency screening. So المسح التشخيصي rather than مفصل. It's not a very detailed diagnosis using flow cytometry, but it is rather how to optimally screen and narrow down كيف إنه نحدد هدفنا من خلال one single tube of 8 color on a flow cytometer. Now, it's just what you know about primary immune deficiency being a group of heterogeneous disorders, and the hallmarks are having recurrent infections, lymphoproliferation, atopy, asthma, dermatitis, even food allergies, sometimes even to the extent of malignancies as a, let's say, complication. Now, they are mostly and chiefly genetically inherited or of genetic etiology, not inherited, because usually are mutations, and sometimes in the case of a heterogeneous mutation, it can be passed on from a parent. Now, historically, we started knowing about autoimmunity from the 20s of the 1900s, starting with ataxia telangiectasia, and as time passed, we got to know more and more about more primary immune deficiencies, and at present we know that there are more than 300 plus different types of primary immune deficiencies. So it's getting more and more complex because with time we are learning more about the mechanisms of lymphocyte development and cell-to-cell interaction. If we consider CDs, clusters of differentiations, the markers on the surface of cells, and signaling pathways, enzymes, it's a lot of factors that are playing all together in one time. And مين فيكم يعرف how many CDs we know at the moment? The number of CDs, clusters of differentiation. We have probably around 400, and the number is growing. Do you know that we do not know ما نعرفش الfunction of many of them? We just identified them, not us, BD, but like scientists, have identified many of these markers. Many we know, they are adhesion molecules, receptors, ligands, and so on. But there are many others who we do not really know what they do. It's this, and this is how we are now gaining more and more insights. And this is why the number of primary immune deficiencies in terms of the etiologic agent is increasing. So there are the predominantly antibody related deficiencies. And it's a very long list. I will not go through them because the focus of the talk is on cellular responses, or cellular deficiencies. And there are the combined immunodeficiencies. And they, of course, have issues with CD8 subsets or CD4 subsets, or the complete absence of T cells, low CD27 positive B cells, progressive decrease in T cell numbers with normal B cells, sometimes with NK cells, sometimes without. Congenital thrombocytopenia and eczema could be a result or associated with DNA repair defects, thymic defects, hyper IgE syndrome. There are quite many. So just to think how كيف هذه البرايمري immune deficiency how it happens إيش كيف لازم نفهم الديفلوبمنت التطور للليمفوسايتس. فإذا بدينا من الهيماتوبويتيك ستيم سيل اللي هي الخلية الأم الجذعية بالعربي، اللي منها يطلع الكومن lymphoid precursor cell. بوجود أو بإنتراكشن أو response ل different cytokines, cytokine receptors, enzymes that facilitate signaling processes inside the cell. This group, and actually it's not limited to this, but these are examples. These are probably the most common ones. So the common lymphoid precursor develops to becoming a pro-T cell at a very early stage. Again, interaction and maturation requiring certain enzymes and signaling pathways. This pro-T cell will start the pre-T cell checkpoint at this pre-cell TCR checkpoint, will further develop to becoming a circling pre-T cell. And again, more processes inside the cell and interaction that would help further develop the cell to becoming the double positive T cell. Who knows where do we find double positive T cells? Do we find them in the peripheral blood? ممكن نصيبهم لكن بكميات محدودة. الكمية الأكبر where we encounter these cells would be in the lymphoid tissues when the T cells are still developing. And then depending on the type of interaction, the environment around these T cells, they will either develop to becoming CD4 positive and lose CD8, or become a CD8 positive and lose the CD4. On the other hand, there are certain mechanisms that would help the lymphoid precursor become a pro-B cell. And again, a set of processes inside the cell as a result of interaction with other cells and the environment around it help drive the pro-B cell to becoming a pre-B cell. And then the maturation of B cell is a bit more complex, because from pre-B cell to immature B cells, we're still talking inside the bone marrow, molasses in French, I think it's called, right? فتخرج as a transitional B cell from the bone marrow and migrates to the lymphoid tissues, where it further develops through interaction with antigen-presenting cells, other T cells, CD4 helper cells, becoming joining in the follicle of the lymphoid tissue and the germinal center, and eventually becoming a mature B cell. And the ultimate in the journey of a B cell is becoming a plasma cell, which is a factory of immunoglobulins. تمام? Because it's very detailed, I did not include it, because we can still have issues with B cells. For example, when we don't have CD40 ligand interaction, it's definitely past the immature stage, right? So there are certain deficiencies that could happen as a result of a deficiency downstream. Okay. Of the common deficiencies that would lead to SCID, severe combined immunodeficiency, which leads to the absence of T cells but having B cells, would be deficiencies in the common gamma chain, JAK3, IL-7 receptor alpha, CD45, the zeta CD3 chain, and so on. Now, if the mutation affected DNA recombination, like recombination defects like RAG1 or 2, reticular dysgenesis, adenosine deaminase, then that would result in both B and T cells being absent in that patient. And that takes us to a design of a tube to screen for primary immune deficiencies. And this was developed by the Euroflow Consortium. Now, the Euroflow Consortium is a scientific consortium. It's not a company. So it's not a product. هذول مش شركة، مش هيئة تجارية. هم scientific consortium هدفهم انهم يعملوا تطوير للفلو سايتومتري في الكلينيكال ابليكيشنز، سواء بالهيماتولوجيكال مالجنسيز، diagnosis, classification، او حتى MRD minimal residual disease، او في البرايمري immune deficiencies. Professor Orfao kindly shared a lot of the data I will be presenting to you with me. from his team and his work. And by the way, Professor Rafau is an immunologist himself. He's based in Salamanca in Spain. So this is the design of your tube. It contains 12 monoclonal antibodies, and it's an 8-color panel. So it's a smart design. يعني احنا زدنا القدرة على نستخدم markers أكثر من عدد الألوان. والذكاء in the design is that they're combining markers that can never ever happen on the same cell. فمثلا CD8 is a T cell marker. Surface immunoglobulin IgD is a B cell marker. ما في أي cell that can have both at the same time. It's either a B cell or a T cell. نفس الشيء for and IgM, or CD19 and TCR gamma delta. So by doing this, you are maximizing the efficiency of your flow cytometer. So if you use them, you will be able to identify 5 different lineages if we add forward and side scatter. Because who knows how many types of cells we can see if we use CD45 plus side scatter, just 2 markers. Who knows? Let us think out loud. Starting with lymphocytes, they would be bright in CD45, right? And low on side scatter. Very well, nicely resolved. We see them. So that's CD40 lymphocytes. We have basophils. Basophils, they would be slightly lower in CD45, but having low side scatter. So now we have 2. Monocytes, slightly larger, so they have slightly more complex. They have granules, so they are to the they are like showing up or above the lymphocyte population. So that's 3. We have the granulocytes, that is 4, and we have eosinophils. They will be bright in 45 and quite high in side scatter. So just by CD45 and side scatter, we identify 5 major lineages. 3 lymphocyte populations. Because of 19, we identify the B cells, CD3, T cells, 1656, NK. And now, based on 2745RO, if we look at the T cell compartment, whether 4 or 8, we can identify naive, effector, and memory, CD4s and CD8s. And we can identify naive B cells, unswitched, switched because of IgM, IgD plus 27 as well. So as you see, there is a lot of data that can be concluded from this single tube. Now, it's important to know and understand for this approach to work, which I will explain in a few minutes, is standardization. You have to standardize everything in the process to be able to use the system properly. ايش نقصد بالstandardization؟ the instrument setup. كيف عملنا ريجلاج للاباري، الفولتاج ديال البي ام تيد، الكومبنساسيون، حتى السامبل بروسيسنج، التايتر، كم نزيد من كميه المونوكلون. تمام؟ كل شيء لازم يكون مقفل عليه، انه we do it in a specific way, we make sure انه it always done the same way. طيب لو اخذنا الماركرز CD3 19 و TCR جاما دلتا، نصيب البي سيلز، نصيب على البلوتس من 1656 هذا مكان البي سيلز، و 19 TCR جاما دلتا مع 1656 هون نصيب البي. هذول يكونوا عندنا TCR جاما دلتا because they are not 19-3, they are 3 TCR gamma delta. So you need to be able to understand. And this is where we expect them to show on CD3 5616, and again where we expect them on the 19 TCR gamma delta because they are TCR gamma delta, not 19. The non-TCR gamma delta i.e. alpha beta T cells, would show here, there, and there. And these would be the CD3 negative, 1656 positive, the NK. So we have identified our populations. Now, this is another example, but I just wanted to show you that now we have color-coded the population. So this is the B, this is the T, this is the NK. If we plot 4 IgM, 8 IgD, gating the T cells, then these would be 4s, 8s, double negatives, double positives. Now, the same dot plot, if we choose to only show the B cells, then these would be the DM double positive, the double negative, only M, only D. So this is how it works. Again, it's just another example, but it's taking it a step further. Now we are identifying the naive B cells. We are identifying the unswitched memory B cells, the switched, which are double negative for M and D. The unswitched would be double positive for M and D, and plasma cells. And actually, I was surprised because I always thought plasma cells do not carry surface immunoglobulins. But in a study, which is also part of the Euroflow consortium, they show that a minority of plasma cells carry IgM. And I think that most probably, I could be mistaken, they could be plasma blasts, not plasma cells, probably. So don't quote me on that. And if we look at IgM with 27, so this is what we expect, or where we expect to see the unswitched being 27 positive. The switched would be, and of course, surface M positive. The switched ones would lose the IgM and have the 27, while plasma cells would have 27 and not IgM. If we look at IgM with 27, we see the switched memory, the double positive DM memory, and the naive B cells. So this is how you would look at the data from the traditional flow cytometrist perspective, because now we will see something different. By the way, I didn't have enough data on T cells, so this is courtesy of Professor Admo. It's an experiment done in his lab, applying the same approach. So 27RA, 27RA, these are the CD4s and these are the CD8s, and we can clearly see we have 4 distinct populations of naive central memory effector and effector memory and terminal effector cells, whether in the CD4 or CD8 compartment. So it boils down to understanding these mini profiles. CD3 positive, CD4 positive. Naive cells would be 27RA positive. Central memory, 27 positive RA negative. Effector memory, 27 negative RA negative. Terminal effector, 27 negative RA positive. Now, yes, sometimes there are still minor populations that can be a bit off when it comes to, so this is not 100% true, but for the majority, as a principle, this always applies. And if you look at the B cells, if they are 27 positive with both IgM and IgD, they would be unswitched memory. If they lost the M and D, they would be switched. If CD19 is downregulated with both M and D negative, then that would probably be a plasma cell. Now comes the new age flow cytometry. So we have used these markers. We know the subpopulations that we can identify based on the markers. Now it's applying a new software that helps separate and calculate data for you. So what you see here are not dot plots. They are called automatic or automated population separation. And they utilize what is known as principal component analysis. تحليل المكون الرئيس. بالعربي. I don't know if it's used in Morocco this term. فconsider لما يكون عندنا in the lab في المختبر، فلو كان عندنا single parameter وحبينا نشوف the spread of data، ايش ندير؟ ايش البارامتر اللي نديره حتى نشوف the spread of data لما يكون عندنا single parameter؟ standard deviation، صح؟ right؟ لو standard deviation يخبرنا كم البوبوليشن غير متجانس او متجانس. لما يكون عندنا مالتي بارامتريك اناليسيس ايش ندير؟ ستاندرد ديفيشن ما يخدمش، لازم نديروا حاجه اخرى، فنعمل حاجه نسميها برنسبل كومبوننت اناليسيس، وهي بالعربي مصفوفات ماتريكس بالماثماتكس، تمام؟ فاللي نعمله انه it calculates the data بشكل جمعي من خلال المصفوفات، وتعطينا رانكينج تقول لنا انه اللي يفرق بين البي سيل والتي سي ار جاما دلتا بوزيتيف والتي سي ار جاما دلتا نيجاتيف والانكا هم هذول الماركرز ليستد، وبيعطينا الكونتريبيوشن اوف ايتش كومبوننت لانها principal components. فthese are the components that led to the identification or the separation of these populations. تمام؟ ومش it's not always necessary to show each and every component. يكفي the top 4 or 5. It depends. نفس الشيء على البي سيلز لما نشوف naive versus switched versus unswitched or plasma, and the T cell compartment with both 4 and 8 arms. Now, if you ask what are these dots, مين يعرف؟ Can conclude each exactly each dot is the mean, represents the mean of a population coming from a donor. فمعناته هنا في عندنا 1 2 3 4 5 donors. فهاي الزون that is created around هاي الدوتس هو the standard deviation of this population. فإذا لأنهم هذول coming from healthy normal donors, any healthy normal donor, if you standardize, and that's why I focused on the standardization, the normal patient or the naive cells, the naive B cells of a normal patient should fall within these boundaries of the 2 standard deviation zone. Same goes for the switched memory cells from that patient, plasma cells, and unswitched. And again, if you look at the T cell compartment, the same rule applies. These dots represent donors or the mean of a donor, and the zone is the 2 standard deviation of the donors. Any normal patient would need to fall within these boundaries. وضحت؟ طيب، وهذا takes us to an example. فزي ما حكينا، زي ما قلنا, just as we described, this is a healthy donor. So you see the zones, and we see the dots, and each dot here represents a cell from the blood of the patient. فشايفين كيف انه الدوتس بالغالب تقع ضمن الزونز هذه اللي معموله. فعندنا هنا الافكتر سيلز CD4s, memory, naive, double negative, naive 8, memory 8, effector 8. Naive B, switched B, plasma, unswitched. We have the B cells, the NK, TCR gamma delta negative, TCR gamma delta positive. So عندنا complete saturation of the and fulfillment of the pattern of an individual who is normal. Now, if we look at this patient, the first thing that hits you is the absence of switched memory and plasma cells. And you could tell that the number of cells in both naive and unswitched is probably a little suppressed. And again, with the T cell compartment as well, especially in the CD4 compartment. Now, this patient was investigated, and it turned out to be a STAT3 deficiency. Another patient, and again, you can see that it's even more drastic than the previous patient. We only have naive B cells, almost complete absence of T CD4 cells and very suppressed CD8s. Even the NK is absent. And in this case, this patient was suffering from IL-2 receptor deficiency SCID. And the last patient who only had NK cells and a complete absence of the different other compartments. Now again, it was a RAG2 SCID deficiency. Now this is a group of patients having RAG1 deficiency when tested with this model, and we can see that there is a range of presence or complete absence of certain subpopulations. So having one type of deficiency in terms of the affected enzyme or marker, in this case it's an enzyme, can have different manifestations. And that is why it is important to use such a screening model and follow it up with a more specific way of confirming. Now this is another example where we see the B cells, T cells, TCR gamma delta. There is a dot plot I did not show because I didn't have space on the slide, but these green cells are NK because they have 56 and 16. Trust me, it's there. And yes, if you take the CD3s, looking at the CD4 compartment, you will see that we have 1, 2, 3, 4 populations, and the same for the CD8. So where you have the naive central memory effector and terminal effector, and these are the profiles of the different subpopulations that we have identified. So now I'm just showing you, it's the same tube, right? But how you look at the data, you can use the advanced software that calculates, and I will come back to this software later on. Or you can use the traditional approach in just looking at dot plots and looking at where you expect to see your populations. So this is a patient, and we see that the patient has B cells, has NKs, no T cells. So thinking what could be wrong with this patient and remembering the pathway of lymphoid development. So the patient has B cells at a percentage of 73%. NKs are present at around 30%. T cells are missing completely, no TCR gamma delta, 4, 8, double positive or double negative. So the deficiency could be in any of these markers, right? Now, why did not we consider ADA or PNP? I mean, it is part of the mediators that lead, if I could say that mediators, that lead to T cell development. Why we do not consider ADA or PNP? Exactly, because there are B cells. If the deficiency was in ADA or on PNP, we would not have B cells. So again, this is how you use your knowledge of development and maturation in kind of narrowing down on the root cause of the problem. Okay, so why not the common gamma or JAK3? Because there are NK cells. Yeah, so because there are common. So this patient was later on confirmed as having IL-7 receptor alpha deficiency, alpha chain deficiency. Was it boy or girl? I'm not sure actually.
Because if it is a girl, it's obligatory JAK3.
So here you have the experience of the professor. So. Okay, so again, courtesy of Professor Admo, thank you very much for sharing this information with us. Now, he has a 6-color machine, and he wanted to apply the same approach, which he did, and you can see that he successfully managed to identify the CD3 positive cells, look at the TCR gamma delta alpha beta, 4, 8, double positive, double negative. And again, because we are using TCR gamma delta, the software allows us to take them out. TCR gamma deltas could very well contaminate the double negative because many of them would be double negative. So when you create this dot plot, you just take out the gamma delta and you only focus on the the gamma delta negative ones, to show the true double negative cells. And if you take the CD8s and the CD4s, then you will have the naive memory, central effector, and terminal effector in both 4 and 8. So it's a very nicely executed tube, and actually you can tell that the color compensation had been done in a very good way, because it's, you know, these square shaped populations, they tell you it's been done nicely. So something you can add on in terms of mini profiling your cells. So we have discussed IgD and IgM 27, but if you consider 38, 24, 21, and 10, that would be probably a more complete profile for immature B cells. Transitional B cells would downregulate 38 a little compared to immature ones. Even IgM is slightly downregulated than immature ones. CD24 is upregulated. Naive cells, they become dim on IgM. They're all still negative for 27, as you see, and they start losing CD38. 21 becomes positive. Unswitched, again, they are D, M positive, 27 positive. So again, here a kind of a discriminator between populations and so on. And if you look at T cell mini profiles, then naive CD4s would be very high on 7, 28 positive. CCR7 is a very good and important marker in understanding or in subtyping T cells. Central memory CD4s, transitional memory, effector, and terminal. So these are the markers you expect to be expressed on these cells.